Alright, today we're going to talk about some properties with exponents that involve multiplication and division. There's kind of three main sections, so this will be the first one. I'm not going to read through all of these, but oftentimes the directions will say simplify something. And these are examples of what simplified expressions look like, and then they have some non-examples at the bottom. So we never want any negative exponents in there. We don't want repeats of bases, so for instance there. And we don't want a power to a power. We want to take care of that, and so forth. So I will show you all of these things. Oh, and also if you check out the last one, like 10 over 4, we can reduce that just like a fraction, okay? And those are things that I'll show you how to do in these lessons here. So the first thing that we're going to talk about here is products of powers with the same base. So for instance, if I look at 3 to the 5th power times 3 to the 2nd power, we can take some shortcuts. And the bases are the same, it's 3 and 3. What I can do here is look at this. Okay, well, what is 3 to the 5th power? Technically, that means 3 times 3 times 3 times 3 times 3. And what does 3 to the 2nd power look like? 3 times 3. Well, if I'm multiplying all this stuff together, how many 3's do I have? Well, I have 7 of them. So this equals 3 to the 7th. So the secret here is, not much of a secret. Let me move that. If you have powers that have the same base, or powers of the same base, you can just add those two things together. So 3 to the 5th times 3 to the 2nd, I could have just done, well, I know that that equals 3 to the 5 plus 2, which equals 3 to the 7th power. So that's our first kind of rule. Whenever you're multiplying things that have the same base, you can just add the powers together. So very quickly, some examples here. So if I have 2 to the 5th times 2 to the 6th, I can just add 5 plus 6 because I have the same base. That's 2 to the 11th. And you can just leave it just like that, okay, for the purpose of today. You don't have to find out the exact answer. Letter B, you have to do a little bit of regrouping here. Use the commutative property to reorder the multiplication. So the 4's are to the same base, so 4 to the 2nd times 4 to the 5th. And then I'd have times 3 to the negative 2nd times 3 to the 6th. And then we can just add these together. And a simplified expression shows that we'll have, so I can add those two together, 4 to the 7th times, and I can add these two together. Negative 2 plus 6, I add 3 to the 4th. And we could leave it just like that. Technically, I guess I should have put this out front. That's okay. A lot of times you'll see the smallest base out front. But anyway, that's how we could write that. And just to clarify here, if I look at this part right here, what does this actually mean? 3 to the 6th is, remember, this. And 3 to the negative 2 is the same thing as 1 over 3 to the 2nd, or 1 over 3 to the 3 times 3, which would be like this. Oops. So basically what can happen here, since we're multiplying everything, we just kind of cross off two factors, and you can see that we are left with 3 to the 4th power, which is what we got here. So that's how that works. Okay. Letter C, again, you'd have to reorder, but since everything's being multiplied here, I could say A, those are my two bases that are the same, add my 4 and my 2 together, A to the 6th times B to the 5th. And you don't have to put the little dot in there if you don't want to. And just to be careful on letter D, remember that if you don't see a power, that means it's to the first power. So I can add 2 plus 1 and get 3, but then take and add negative 4, I get y to the negative 1, which is not simplified. I'd have to go one step further and say, well, this is the same as y, or 1 over y to the first, or just 1 over y. Alright, so that is multiplying powers that have the same base.